Hello. I think we're live. So welcome all to our webinar about Amazon OpenSearch service. For today's session, we will have the following agenda points. As this webinar is hosted by AWS and Zoe, I will shortly introduce to you what we do and who we are. And after that, Francisco from AWS will introduce to you OpenSearch service and how you can migrate. Then we will have. Then I will present you how we use OpenSearch at Zoe with 2 examples. And at the end, we will join the YouTube chat and try to answer questions you have. But we also have colleagues already in the chat, so feel free to ask your questions already. So first of all, hi to everyone. My name is Tobias Leitner. I'm a software developer at Zoe. I was working with in several Elasticsearch and now also OpenSearch projects within different customers and also different sizes of the projects. I am a AWS certified solution architect, and I am located in the Berlin office of Zoe. So who is Zoe? It's an abbreviation for 01 Infinity. We describe our DNA as digital, which for us means that we want to close the gap between our enterprise customers and the new technologies. And how do we do this? We are not only a consultancy company that offers solutions, but we also implement them. We like to be present at our customer site because we believe that, especially for complex projects, it requires local cooperation and presence. And our mission is not only to generate future-proof solutions, but to generate real value, which is added to the business of our customers. Having said all of this, we have more than 10 years experience within the public cloud. We also have several proven cloud competencies in different areas, and more than 180 of my colleagues are cloud certified. With our 7 locations around the world, we can not only cover the 9-to-5 area, but we're able to support daytime, nighttime support for our customers. And of course, we are locally available to most of the sites of our customers. Currently, we are more than 300 employees worldwide from 30 nations with a variety of different skills that helps us to cover complex problems and look at them from different angles. So if you are interested in joining us or want to know more about us, feel free to contact me or any of my colleagues. On this slide, you can see our customers. All of them are leaders in their fields, and we are maintaining a long-term relationship with all of them. So now I will hand over to Francisco, which gives us a dive into OpenSearch service and how we can migrate and how migrations work. So Francisco, stage is yours.
Thank you, Tobias. Let me share my screen. Okay. So let me know when you see it. Good. Do you see the presentation now?
Yes.
That's great. 1 second. Perfect. Okay. So hello and welcome everyone to this webinar. My name is Francisco Gonzalez. I manage the partner program for the Amazon OpenSearch service. I'm very happy to be here with Zoe. Working with Zoe is always a pleasure. They're very strong with OpenSearch and OpenSearch migrations. We have a very busy agenda, but very interesting. First, we're going to provide you with an overview of the Amazon OpenSearch service. The Amazon OpenSearch service is the managed service for the open source community project. So we are going to cover both the Amazon Open Service and the community project, including benefits, features, and use cases. Then we're going to cover the reasons why customers are looking to migrate to Amazon OpenSearch service. This is key because it will provide you with the information about why OpenSearch service is a fantastic service for your log analytics, observability, security, and search workloads. Okay. Then we will go over the migration process, a 6-step process that starts with planning, a proof of concept, and ends up with a completed and successful migration to Amazon OpenSearch service. So let's start. So first, why OpenSearch? These two are the two main use cases. First, we're going to talk about log analytics and observability, and then about full text search and full text search. Log analytics and observability is about management of human and machine or system generated data, structure and semi-structure, and data may be coming from websites, applications, systems, networking, social networks, IoT, and so on. You may need to correlate these logs with other metrics and traces or business insights, and also use advanced features such as machine learning and anomaly detection. Common samples are performance and security monitoring, alerting, auditing, and also security purposes. Then is search and full text search. Our applications require very fast, real-time search at a scale with relevant results coming from structured and non-structured data or semi-structured data. Use cases here include a document portal, e-commerce, machine learning, and customized or personalized recommendations. OpenSearch is based on Lucene, so it's using an inverted index. So that means it's able to produce results really fast for data coming in real time. So it makes it a very strong offering. So let's now talk about the OpenSearch open source project. OpenSearch is an open source community project. We have the open source project, and then we have the Amazon OpenSearch service. Amazon OpenSearch service, one more time, is the managed service for the OpenSearch community project. So let's cover now the OpenSearch community project, and later I'll talk more about the service. OpenSearch is a community-driven open source project for search and analytics, and is derived from Elasticsearch 7.10. This was done about 18 months ago. Amazon is committed to the project, and there are also other large organizations that are also contributing to this project. OpenSearch has advanced features, and the team is releasing new features every quarter. Some of the advanced features include high cardinality anomaly detection, trace analytics, OpenSearch dashboards, and many more. You can see the project roadmap at opensearch.org. Some of the very relevant new features are the security plugin and also the observability plugin. So let's talk now about the benefits of an open source project, that is OpenSearch. So it's 100% open source, and this is key. So you as a customer can see, review, change, improve, or monetize the code. This is very relevant. You can build solutions on top of OpenSearch without paying a license. Let me see, everything is working. 1 second. It is, okay. Without paying a license. It's community driven, so that means that any organization or individual can contribute and influence the roadmap. This means that they're able to really capture the market and customer needs because it reacts faster to market trends and customer needs. And it's enterprise ready, since Amazon is pushing for this community project and has an enterprise managed service built on top of OpenSearch. That's the Amazon OpenSearch service. It has an enterprise mindset, and this translates to more secure, more compliance, easier to manage, and to scale. So let's talk now about the managed service. That is Amazon OpenSearch service. So It's the managed service for the OpenSearch project, and it includes OpenSearch, OpenSearch dashboards, and it also supports existing customers using previous versions of Elasticsearch before the release of OpenSearch. So we have the community project, and then we have the managed service. That is Amazon OpenSearch services, and this is what customers buy from Amazon. So Amazon OpenSearch service enables customers to easily ingest, secure, search, aggregate, view, and analyze data at multi-petabyte scale without the operational cost of having to manage your own cluster. No one likes to manage OpenSearch or Elasticsearch clusters, so Amazon OpenSearch service, it's great since it really takes out of you the operational cost. This is key since you can scale up to 3 petabytes and 200 nodes in a single cluster. And if this is not enough, you can deploy a second cluster and then use the cluster cross capability features in search and for other features. So let's now cover the benefits of Amazon OpenSearch service and why customers are migrating to the service. Okay. So on top of the new functionality you get with OpenSearch, because the OpenSearch project is moving really fast, such as the observability plugin and the security plugin, the main three benefits you get with Amazon OpenSearch services are management and scalability. You can have a very large customers, as I said before, 200 nodes and 3 petabytes. Very easy to manage with cross replication features, active, passive, upgrades, backups, and more. So Amazon OpenSearch service scales, and this is very important because the existing installation for log analytics and search doesn't scale, or scaling is very complex or hard. So this is one of the main reasons customers are moving to Amazon OpenSearch service. Data is growing exponentially, and customers need a solution that scale. Then is price performance. With Graviton processors, you get 44% better price performance. On top of that, you have ultra warm nodes and cold storage with the potential of an 80% cost reduction compared to your self-managed, on-prem, or using other solutions. So this on top of the great pricing you get because it's a native AWS service. And remember, since OpenSearch is open source, you're not going to be paying for a license. Great. If anyone has any questions, please feel free to ask them in the chat. We have a team supporting you during this chat, and we can also cover the questions later on. So another reason is security and compliance. You can rest assured knowing that you have the latest security available, such as encryption with the key management services, Cognito, SAML, 24/7 monitoring of your cluster, and many more. You're also in compliance with many standard and industry regulations, such as ISO, FedRAMP, SOC, and more. So this slide has got the difference between you managing your OpenSearch installation compared to using the managed service. So in the right, we have the scenario for you using Amazon OpenSearch service. In this case, Amazon is taking care of everything. So you only need to worry about your business, the application, the functionality, and so on. Amazon takes care of the rest. If instead you're in the middle, that means you're using EC2. This is Amazon Elastic Cloud Compute Cloud, and then you are installing and managing OpenSearch. In this case, Amazon only take care of the hardware and operative system, the lifecycle, power, network, and cooling. But you not only take care of your business and the application, you also need to figure out your high availability, backups, 24/7 monitoring, hot nodes, cold storage, cluster scaling, upgrades, patching, and so on for OpenSearch. If instead you're not in EC2, you are on premises, in most cases, you're using your own hardware on premises. So now you will need to take care of everything, including building security, hardware, cooling, and networking. At the end, On the right, the Amazon OpenSearch service gives you the most comprehensive solution to run your OpenSearch workloads at scale with price, performance, and security. So in terms of price performance, since May 2021, Amazon OpenSearch Service supports Graviton processor instances. So they are designed by AWS and provide better price performance for a broad range of workloads. They also help customers reduce their carbon footprint. In OpenSearch, we've seen 44 better price performance when using Graviton processors. In this chart, you see a 38% improvement in indexing, 50% less indexing latency, and 40% increase in query performance. Uh, you can also get an increase in price performance by taking advantage of ultra-warm nodes and cold storage. Ultra-warm nodes provides you with 90% cost reduction. It's using S3 and a cache solution, and it only supports reads in S3. So if you need to write, it will automatically return the index to the hot storage, and it still has the 3 petabyte limitation and has less query performance compared to hot nodes. But the great benefit is that it is transparent for your application and users. They only see a very small delay, a very small decrease in performance. The most common use case is when you rarely use historical data, let's say data older than 5 years old or 3 months old, whatever is old for you. In that case, you move your historical data to ultra warm nodes, so you get an 80% cost reduction. Another strategy is cold storage. Cold storage is using S3 infrequent access. In this case, data is available only on demand. The indices are moved to S3 infrequent access, and there is no data limit. So no 3 petabyte limit here. You can move as much data as you want. The only problem is that you have on-demand access, meaning that in order for you to browse your data, you need to move it to an ultra-warm node, and that is somehow a manual process. So customers with large volumes, these are customers out there ingesting terabytes per day, are using multiple clusters and warm nodes and cold storage strategies. So let's move now to security. Amazon OpenSearch Service is actively monitoring your clusters. If a cluster is not working well, it's a performance issue. Let me see. Oh, hold on. It's a performance issue, but if a cluster is not working well, it's also a security issue. Amazon OpenSearch Service provides automatic replacement of failed nodes. So we also don't need to incur in the operational cost of replacing these nodes. Amazon OpenSearch Service supports data replication for your cluster across 3 availability zones, making it very secure and reliable. Amazon OpenSearch Service also supports cross-cluster with cross-region replication for active passive. We have customers with passive replicas in different continents, making the whole experience faster for their customers. Let's check everything is good. Everything is good. Great. Good. So now, let's now that we understand more about why we want to, we will be able to scale and improve price performance and take advantage of all the new functionality of the OpenSearch project, including the observability and security plugins. There are many other log analytics and search solutions, such as Solar, Splunk, or Datadog, facing the same problem: growing data volumes that require scalability, security, price performance, and advanced functionality. And is more complex than that. There is also many customer migrating workloads from Splunk, Solar, or Datadog. These migration projects require more work, but in the end, it provides the functionality that customers require at a scale with price performance. So let me check everything is good. Okay. Um, so now I have the 6-step process on the screen. A log and search migration can be very complex. During this presentation, I'm providing you with a very high-level overview of the migration process. In this case, we have a 6-step process. The first step is qualify and plan. This step is about sizing and planning the migration. Then we have the a proof of concept to validate the plan and identify any issues very early in the process. Then we jump into deploying the target solution, copy the data, then we update the target solution in preparation for the swap, and then we swap to the target or new migrated solution, and hopefully everything will have worked correctly, and we have a new solution in place. So let's see these steps in detail. Great. So let's start with qualify and plan. The planning section includes understanding key performance indicators for the migration, a review of the functionality needed, including dependencies for plugins. It also includes operations and security, the deployment framework, and how data is ingested. We also look at sizing in terms of what resources are needed for the target destination, and we also plan for training and adoption for the migration team, um, and also operation and the business. You gotta count that you gotta be running your workloads in a different solution, so there's gotta be plenty of training for everyone in the organization. Great. In the business continuity section, the first question we need to ask ourselves is, does business revenue depend on the current solution? This will give you a good idea of how critical this solution is for the business. Then you start building key performance indicators for the target system, such as operational performance, latency, input and output, process performance, SLA, uptime, or time to resolve, or other business performance metrics such as search results or business aggregations. Um, Good. Okay. Um, Perfect. Let's now move to sizing the solution. So there we go. If we are migrating from an Elasticsearch solution, then we have a good understanding of the storage and CPU needed for selecting the instance type. If we are migrating from another type of solution, then the sizing section is a little bit more complex. If we are sizing in terms of storage, an index with one replica is about 2.5 times the size of the source data, and we always leave about 25% overhead. In addition, you also need to estimate the weekly or monthly growth. In order to provision CPU, a good quick rule is to have 1.5 CPUs per shard, virtual CPUs per shard, with for substantial traffic. Now, this is just a quick overview. In the end, the best way to estimate is by doing a small test, simulating a section of your current workloads. A small test will really make a difference for estimating the size that is needed. So now let's jump into functionality. And we are still in the planning phase. As part of the planning, it's key to identify all the systems we are integrating with and what is the functionality required. If we're migrating from Elasticsearch, this may be a very simple step since OpenSearch is derived from Elasticsearch 7.10. But even in this case, there are some scenarios that require some effort in the migration process. If we are migrating from other log analytics and search solutions, some further work may need to be done, such as modifying the existing applications or building custom code to replicate some of the integrations so it's transparent for the other systems. As with any migration, there may be some functionality that is different in OpenSearch. So it's important to plan these specific scenarios in very detail. Good. Let's move to data ingestion. So this is a key part of a log analytics and search solution. The first step is to review in detail the current ingestion framework. In some cases, we may use the same ingestion framework that you already have. But in many other cases, we may want to modernize the framework by using some very powerful platforms or tools such as Kinesis, Kafka, or use some open source plugins such as Logstacks or Fluentd. Good. And then is in the planning section is training and adoption. So you need to build a comprehensive plan for training and adoption for your different teams. Your existing developers need to understand the new solution, so when they build applications, everything integrates smoothly. Then is your operations, support, and security teams. As said, Amazon OpenSearch service is a managed service, so your team will have a lot less to do compared to when running on-prem or self-managed. And then it's also the business team, your business users. They may interact directly with the existing platform, so they need to get used to the new UI and how results are presented. In most cases, if it's search, is how the search results are managed, or if it's a log analytics solution, is OpenSearch dashboards. Great. Then it's time to jump into the proof of concept. This is uh, the section I like the most, because during the proof of concept, we validate the key functionality. The idea here is to build the runbooks, review integrations, and we also review the budget to make sure everything is aligned with the planning. The sooner we discover issues, the better. I like to think of a proof of concept in a migration as a way of discovering what is going to fail, so we make sure that the planning is correct. The result of the proof of concept is a validated plan to execute the migration. Then it's time to deploy, and let me see, 1 second. Great. Perfect. It's time to deploy. So in this step, we execute the deployment scripts and review security, monitoring, and alerts. Um, we perform a security penetration test and review that integrations are working. In the end, after the deploy, the system is ready for data copy, ingestion, and sync. Um, so that way we can do a swap later. In most cases, what takes the most time is making sure that all integrations are working well. Some of those integrations may have required some work in a previous step. So sometimes a small test with sample data is something that makes lots of sense during the deployment phase. Good. So now before we copy the data, let's move to data migration patterns. So in this step, we're loading the data into the deploy solution that we are migrating to. The complexity of this step really depends on the systems we're loading from, the size of the data that we need to move, and the channel we're using for moving the data. Bandwidth, reliability, and security are key aspects when moving data. Sometimes we have a very fast connection that is secure and we can rely, but some other time this step may take days because of a slow connection or very large volumes of data. The last thing we need to look at is how we are extracting and transforming and loading the data. Okay, so for this we have three different options, and you can see them on the screen. The easiest one, the one in the middle, is when we are restoring from an Elasticsearch or an OpenSearch snapshot. That is the easiest one. In Not in every case we're able to do this. The one on the left is when we're loading from the real source of data. So there was an existing solution that was consuming from the source, and now the new solution is also going to be consuming data from the source and copying the data from the source. And then the one in the right is when we are loading data from an existing application, we're copying the data or search engine, and then later we will start ingestion when the data is copied and is up to date. So let's start with loading from the source. So when we are loading from the source of the data, we're loading from business systems or repositories. The OpenSearch API is expecting a JSON. So if we're not able to collect data in JSON format, we will need to transform it to a JSON. In most cases, data is currently hosted in a database or in a storage system. If it lives in a database, we may be connecting to SQL Server, Oracle, MySQL, DB2, and so on. Or we may be connecting to business systems such as SAP or Salesforce. We could also connect to a NoSQL or key value store or file systems, and data may be in different formats. When we're building from the source, we need to transform the data, and in some cases, you may end up building your own custom code to transform and load the data, and maybe you're running this code in containers, EC2, or serverless Lambda. You can also use connector-based tools such as FluentD, Data Prepper, and Logstacks. These software connectors are ready for you to use and make the collection, transformation, and loading much easier. You can also run this in containers or in EC2. Then is the extraction, transformation, and loading tools that you can also use, such as AWS Glue. AWS Glue is a great tool for extracting, transforming, and loading your data. AWS Glue has support for views, making it easy for you to load data into Amazon OpenSearch service. Now, the next option that we have is loading from a snapshot. If you're very lucky, this is something that will work for you. So you can easily take a snapshot from your current on-prem or self-managed Elasticsearch or OpenSearch. Newer versions of OpenSearch in most cases read the last major version. And once you restore the snapshot, we strongly recommend reindexing the data once the snapshot is restored. So plan for the CPU needed to restore before going live. Another option is build from the 16 engine. Let me pass the slide here, make sure everything is good. Okay. And so another option is build from the 16 engine. So in most cases, the 16 engines make it easy for you to extract the data, but in some cases, it's not that easy. There are different ways you can extract the data from an existing engine. You can always create your custom code and run it in EC2 or containers, as I said before, maybe in Lambda. You can also use AWS Glue to build integration or a plugin such as Logstacks. And when connecting to an existing engine, there is some planning that needs to be done in advance related to security, network, and authorization. So hopefully, after reviewing these 3 data loading options, that is building from the source, snapshot, or building from the 16 engine, you're ready to move to the next step. And next step is to do an update and sync of the current replica we have. So in the previous step, we were loading data, and maybe loading data took a day or a week because it was terabytes or even petabytes of data. Now it's time to update to so that way we can do the deployment and the swap to the current data. If it's a log analytics, you may be able to run both systems side by side, and having both systems ingesting data and then backfill with prior data. If it's search, ingestion may need to be stopped, then run some type of CDC, change data capture mechanism to backfill the changes to start ingestion again. So it really depends on your source systems. If they allow you to have CDC, then it's easy to do an update. Maybe you will need to run ingestion in parallel, so each migration is different. And then finally, you have the last step. It's time for the swap. Once we are in ingestion and data is flowing to the current environment, and the integrations with other systems such as front-end applications are working, it's time for the swap. This step may require changes in the front-end application or DNS changes to point to the new system. In many cases, we need to consider a rollback plan. This is something you need to decide at the very beginning in the planning phase, and it depends on what is the business's impact if we have a long downtime. So, okay, so now we have a high-level understanding of the migration process. This is high level, but we wanted to provide you a quick overview. The migration process is covered in detail in migration workshops that you may have for your team when doing the migration, and you should go in details on each different step. This is a very high level presentation of the migration process. So let's wrap up. So we cover the open source project and the Amazon OpenSearch service. Remember, the main reasons why customers are migrating is because functionality. The OpenSearch project plus the Amazon OpenSearch service has got great new functionality, including the security plugin and the observability plugin. Price performance. As said, you may get up to 90% better price performance because of introducing warm nodes and ultra warm nodes and cold storage, and also because using Graviton processors. Management and scalability, you don't need to worry about your the operational cost of dealing with your nodes within your cluster. And security. Remember, Amazon has an enterprise mindset for the OpenSearch project and also for the Amazon OpenSearch service. Then we saw a 6-step process for migrations. Very high level, but I think it was a good overview for you if you are considering starting a migration. And that's about it. So, and thank you. And let's see some use cases from Zoe. Tobias?
Thank you very much, Francisco. I will again share my screen. All right. Okay, so now that we know what OpenSearch service is and how we can migrate, I will now switch to some use cases we are working on. Coming to the customer use cases, our first example we are doing at Zoe is a customer that produces cleaning machines that sweep and scrub floors for professional environments, such as airports or shopping malls. You may have seen them already somewhere. Most of the machines are operated manually, but there are also more and more autonomous ones. Each of the machine has a TCU, which is a telemetry control unit on board. That is basically a client that connects to a MQTT broker via cellular network. And these machines are sending telemetry data that informs about the current status of, for instance, of the water level of the tank, or battery status, information about locations, and other things that are gathered from the many, many sensors on board. On this slide, you can see a high-level diagram of the machine data and how it is processed to the OpenSearch cluster. This diagram does not show any security aspects or other services involved, so it's really a basic high-level architecture of the process flow. So as you can see on the left side, there's the devices that connected to the MQTT broker of the AWS IT core service. The data that is collected by the multiple sensors is sent to specific topics, which are used for communicating with the machine. Also, they are used. Rules are used to route the data to a transformation pipeline, which can consist of Kinesis data streams and lambdas. After all of that, we are storing the data into our in one of our DynamoDB tables, and of course we index it to the OpenSearch cluster, from where we use REST APIs provided by the API gateway to run queries for web clients that use this kind of data. Those web clients are used by stakeholders and customers, as I said, to show the data of the machines. I will come to that on the next slide. We also use the OpenSearch dashboard to perform internal development, to run queries, to test example data. And additionally to the telemetry data, we also index firmware update information. For each machine that runs firmware updates, those status messages are also indexed and can be displayed. And for this use case, we are really happy to have OpenSearch because it gives us a very fast way of executing queries, and also using aggregations for the data to be displayed. So on this slide, you can see on the left the sample dashboards. You have a lot of options to filter and aggregate data for either one machine or multiple machine types. Our queries are focused on performance. That's why we use standard analyzers. We also use explicit mappings for our indexes. And also, as I said, aggregations, which are helping us for our filtered requests. For those of you who don't know what an analyzer is, it's basically a combination of methods that perform some actions on a field that is indexed. An example is one analyzer could be that one field is one sentence is transformed to lowercase and also split into each single word. For the firmware data, we use join field types that allows us to generate a parent-child relationship between the machine data and the firmware update. And also we follow the best practices and the recommendations of AWS and the community to use dedicated master nodes and data nodes, which helps us a lot to find the right sizing of the cluster and also have the best ratio between performance and cost. This solution was implemented on Elasticsearch, also in AWS already, and we migrated to OpenSearch 1.0 lately. The migration was smooth, and we could use the snapshot method, and we had no interruptions on our system. For the next use case, the second one is a website search. Our customer has different sources of information that needed to be searchable on their website. For that, we were building some crawlers that retrieve the information of the different sources, like products, job offers, patents, presentation, and so on. Those data were transformed and indexed into dedicated indexes in the OpenSearch service in the cluster. Then we also provided a REST API to query different endpoints for the website website. And this, we had to provide several different endpoints and search capabilities like auto completion or word suggestions. For that, we used a lot of custom analyzers, which we used for indexing already and also for the querying of the documents. This service still runs on Elasticsearch engine inside of the OpenSearch service, but we are already in the process of migrating the data. In this example, OpenSearch was really helpful because we had huge amount of documents to index, so the scalability was on point, and we also had appreciated the customization ability of the search endpoints. All right. So if you want to know more about our use cases or about Zoe or about anything related to Elasticsearch, to OpenSearch service, you can contact us on different channels. Francisco and I will also join the YouTube chat now and answer some questions if there are any. And I want to thank you, Francisco, for giving the opportunity to us for holding this webinar. And thank you, everyone, for being part of this stream.
Thank you very much for hosting this. Thank you.